Questions 5 to 9 in the ACER green paper. Question 5. Of the following, the most polar bond will be a covalent bond formed between atoms of. So the most polar bond will be formed between the two atoms that have the greatest difference in electronegativity. So in our first pairing, we have chlorine and fluorine. So chlorine has a electronegativity of 3.16 and fluorine has a electronegativity of 3.98. So to find the difference in electronegativity, we simply subtract one from the other. And this gives us, if we just do all of the subtraction, a difference of 0.82. And if we go through all the pairings, we will get something along the lines of this. So if you just take a look at all the differences in electronegativities, you can clearly see that sulfur and oxygen have the greatest difference in electronegativity, and therefore they will have the most polar bond, and therefore for question 5, B is the correct answer. Question 6. In one part of a molecule, there is a carbon-oxygen double bond, while in another part there is a nitrogen-hydrogen single bond. If these two parts of the molecules were sufficiently close together, there would be. So first off, we need to figure out the delta values for each of these atoms, and we can do that by using the information from that first line in the paragraph in the stem. And it states that in a covalent bond, the atom that is more electronegative will have a slight negative charge, denoted by delta minus, while the atom that is less electronegative will have a slight positive charge, so denoted by delta positive. So we have two atoms here and they are covalently bonded as indicated by these lines, and we know that carbon has an electronegativity value of 2.55 whilst oxygen has a value of 3.44. So oxygen is going to be more electronegative and therefore will have the slight negative charge, whilst carbon will have the slight positive one. Hydrogen and nitrogen, on the other hand, well, hydrogen has a electronegativity value of 2.2 whilst nitrogen has a value of 3.04. So in this case, nitrogen takes the delta minus whilst hydrogen takes the delta plus. In the second paragraph, we have another really important line, and it states that in most organic molecules, the greatest electronegativity difference most commonly occurs in bonds that have a hydrogen atom at one end and an atom of oxygen or nitrogen at the other end. In such bonds, the hydrogen atom has the slight positive charge and so will be attracted to the lone pairs of electrons on the atoms of oxygen and nitrogen that occur in the bonds in the same molecule or in different molecules. This attraction is called a hydrogen bond. So we've got that exact scenario occurring here. We have a hydrogen on one end and an oxygen on the other. So therefore what they're going to be forming is a hydrogen bond. So what we can do now is look at the answers in question 6, and the correct answer is answer C, because it states that there would be a attraction of the hydrogen atom in one part of the molecule to the oxygen atom in the other. And that's exactly what we've got going on here. We've got this hydrogen bond attraction between the hydrogen and the oxygen, so therefore C is the correct answer in question 6. In question 7, we are asked to find the positively charged ends of the two bonds, and we're given the two pairings, carbon and nitrogen and sulfur and hydrogen. So the delta positive and the positively charged end is going to be the less electronegative end. So in carbon and nitrogen, we've got carbon of 2.55, nitrogen with 3.04. So therefore, carbon is going to be the delta positive end. And with sulfur hydrogen, we've got 2.58 for sulfur and 2.20 for hydrogen. So therefore hydrogen is going to be the delta positive end. So therefore for question 7, B is the correct answer. Question 8. Of the following, the attractive interaction between atoms of two molecules that are the same distance apart would be strongest in. So again, we have this dipole-dipole bond being formed. So what we need to do is we need to figure out the delta negative and delta positive values for each of the atoms in the dipole-dipole bond. So in carbon oxygen, well, carbon is less electronegative than oxygen, and you can find that in the table, and therefore oxygen has a delta negative value. Similarly, nitrogen is more electronegative than carbon, so it will have the delta negative value. And you go through each of the atoms in the dipole-dipole bond and assign them their respective delta values. So once you've done that, you'll find a couple of things. 1, A and C are not dipole-dipole bonds, and that's because we have the same delta value on each of our bonding atoms. So oxygen has a delta negative value, nitrogen has a delta negative value. Dipole-dipole moments only occur between atoms that have opposite delta values. So A and C, they're both not dipole-dipole bonds. B and D are, but so whilst B is definitely a dipole-dipole bond, has that delta negative with the delta positive, same with D. D is stronger, and the reason why is because D is an example of a hydrogen bond. So a hydrogen bond forms between a hydrogen that has a delta positive value and a nitrogen/oxygen which has a delta negative value. So whilst B is a dipole-dipole bond, it is not a hydrogen bond, but D is definitely a hydrogen bond, and hydrogen bonds are stronger bonds than dipole-dipole bonds. So therefore D is the correct answer for question 8. Question 9. Of the following, the factor that has the least effect on the strength of a hydrogen bond in a molecule is Z. So there are two really important things about hydrogen bonds. One is that it is a bond between a hydrogen and a oxygen/nitrogen. And two, the hydrogen must be delta positive and the oxygen/nitrogen must be delta minus. So the type of atom to which the hydrogen atom is covalently bonded is going to be very important, because depending on its electronegativity value, this hydrogen will either be delta positive, in which case we'd get a hydrogen bond, or it could be delta negative, in which case a hydrogen bond would not occur. So say for example we get this hydrogen is bonded to phosphorus, which has a lower electronegativity value than hydrogen. Instead of being delta positive, this hydrogen would be delta negative, and therefore a hydrogen bond would not exist. So the atom to which this hydrogen is covalently bonded to is important in determining whether a hydrogen bond even exists. So A is incorrect. B. The distance that the hydrogen atom is from the atom on the other part of the molecule. Well, that just makes sense. If this hydrogen is nowhere near this oxygen/nitrogen, then it's not going to form that hydrogen bond. So therefore, B is incorrect. C. The number of hydrogens attracted to the atom on the other part of the molecule. This pretty much won't have any effect on the oxygen/nitrogen, so we can say that C is probably our answer. And lastly, let's rule out D. The type of atom in the other part of the molecule to which the hydrogen atom is attached. Again, that is very important. The hydrogen needs to bond to an oxygen/nitrogen for it to be a hydrogen bond. If it's something else, it won't be a hydrogen bond. So therefore, C is the correct answer for question 9.